All right, so in this video, I'm going to be talking through page 9 of the notes packet. This is where we're going to be doing graph characteristics. So we're going to be looking at the intervals for which the graph is positive or negative. Remember, positive means that the function is above 0. So here we're just simply trying to figure out for what x values is the function positive. And so if we let green represent positive, we can see that the function is positive in this area here, right, for these values of x. And for these values of x over here as well. And why is that? Well, that's right here is where the function equals 0. So up here we're positive, and where is the function rest up here? Well, it's here and it's here. So then how do we write this? Well, we're going to have two different ways to write this. We're going to have the set notation and the interval notation. In the set notation, we're going to put our curly brackets, x where -8 is less than x is less than -3. And notice how I'm just doing less than here. I'm not doing less than or equal to, because at these endpoints it's equal to 0. So it is neither positive nor negative. Or, right, that's how we connect two inequalities. 2 is less than x is less than 8. All right, we can represent that using our interval notation too, where the first interval is going to run from -8 to -3. Then we can put this U shape. That U shape means union. It means we're kind of taking either in this interval or in that interval. And that's going to run from 2 up to +8. All right, and then the negative intervals, well, that's kind of the opposite, right? Those are the other places. So where is this graph negative? Well, that's over here, right? Stretching on to infinity, and over here, right in the middle, that's where it's negative, and over here, that's also where it's negative. So we can represent that again in set notation. We're going to need a little bit more space than I gave you here. I apologize for that. X where -infinity is less than x is less than -8, or -3 is less than x is less than 2, or 8 is less than x is less than +infinity. All right, and then for the interval notation, we can write that -infinity, comma, -8, union with -3, comma 2, union with 8, comma, infinity. All right. So that's positive, negative intervals. We also have increasing, decreasing intervals. So increasing, decreasing is when you read from left to right. If the function is going up, then it's increasing. If it's going down, then it's decreasing. So if we look at where is it increasing, well, those increasing intervals, that's going to be from here over to there. Right? It's increasing on those intervals, and it's increasing from here all the way over to there. Right, because these are the places where when you read the graph from left to right, the graph is going up, right? It's going up there, it's going up here. These are decreasing, so it's going down and it's going down. So we can represent this in the same way. All values x such that x is -infinity less than x less than -5, or -1 is less than x is less than 5, which we can represent as intervals as being -9, comma, -5, union with -1, comma, 5. All right, and then the intervals of decrease, those are the opposite ones. So that's where the graph is going down. And so that is from x where -5 is less than x is less than -1, or 5 is less than x is less than infinity. And then for the interval, we can do -5, -1, or 5, infinity.